after having put down the lists, I tried to figure out how to write this kind of algorithm, and then decided, okay, I start with this.
Good morning, everybody. Here are the guys from Germany. My name is Thomas, and my guests today are Frank. Good morning, Frank.
Hello, Thomas. Hello, Achim.
And Achim. Hello, Achim.
Hello, Thomas. Hello, Frank. Hello, world.
So both guys were very fast today, and Achim will introduce us his Java solution. Achim, please tell us about the riddle and your solution.
Okay, for the riddle, we have a toy boat, and we need to race against a time that someone else has set up. So for the first part, we have said that we have a piece of paper which describes 3 races with times of 7, 15, and 30 milliseconds, with a maximum achieved distance of 9, 40, and 200 millimeters. They are toy boats. Our own boat is defined as having a starting speed of 0 millimeters per second. We have a button that we can push, but each millisecond that we push it, the boat doesn't move. If we don't push the button at all, it doesn't move at all. If you push the button over the entire time, the boat doesn't move either. So we have some kind of optimization problem. Consider a parabol curve that is opening to the so some kind of curve where somewhere is a maximum. We don't need to find the maximum. We just need to find any single race in which we achieve more distance than the recorded record. So what I did for the first part, parser wasn't required today because we just have a list of times, we have a list of distances. Here are my puzzle inputs for that. It's just one more. So I go through these pairs and attempt to beat the record for the time and distance. And here I have the method. I start at pushing the button 1 millisecond because I know if I push it 0 milliseconds, the thing doesn't move. So it's not very interesting. And calculate the distance by the number of milliseconds I push the button and the remaining time. So if I push it long, it has only little time left to move at all. And then I check if this calculated distance is bigger than the given distance. If it is, I save this time and break the loop. And I do the very same, starting from a maximum time, moving into the other direction. So I get the minimum. So minimum gives me the minimum amount of button pushing that allows me to beat the record. And max gives me the maximum amount of button pushing that allows me to beat the record.
Okay, what is the benefit of doing this?
And any option in between must provide an even further distance.
Yeah.
So I don't need to check everything. I only need to check these.
Also you check minimum, maximum, and everything between is also a valid solution.
Exactly. And the point is, we have to return the number of instances in which we beat that record. It's not important by how much we beat it, we just need to beat it.
Okay, I understand.
So if I take the maximum minus the minimum plus 1, because they are both included, I get the amount of times I would beat the record. And these we have to multiply up and put out.
Okay.
That's for part 1.
But actually here, the part 2 you implemented is still of a complexity of ON with the race time, and the part 1 is also, so you could use the part 1 algorithm for the part 2 as well. So there's no need to implement 2 different things.
I couldn't because I used integers and I didn't want to rebuild everything.
It's the same. It's the same.
Yeah,
the numbers are so small that it works.
If I had started with longs from the get-go, I could have reused the method in part 2 as well.
An interesting question is if we would have really big numbers like billions or trillions, then the part 2 algorithm would be right, but then we would not do a linear search for the values min and max, but then we would do a binary search on them, and then we could do it for really huge values.
But no need for this riddle this time.
Yeah.
If it was with really huge values, I would need to switch over to big integer. And that is performance-wise a huge hit.
Yeah, if you use a binary search to search for minimum and maximum, you search only the number of bits of this number. So if it's like 64-bit numbers, you only have 64 loops, so it's still very fast.
But we jump ahead a little here because we haven't told what the twist of part 2 is. So
okay,
these times and distances that we got, they aren't 3, they are 1. So we have, for part 2, we have just 1 race, but with way bigger numbers. So we have to concatenate all these together. And you see here, I had to use a long postfix to declare the Java compiler, hey, this is a long literal, not an integer.
Okay. Nice. That was all for the riddle. That was all.
Yes.
What was the hardest challenge for the riddle for you and for Frank?
So for me, it was this. In the end, I summed up all the numbers from the 4 races, and then later notified that we have to multiply the numbers, not add them. Yeah, it cost me some minutes.
Okay. And Achim?
After having put down the lists, I tried to figure out how to write this kind of algorithm, and then decided, okay, I start with this. So I had the multiplication right from the beginning, and with that out of the way, it wasn't somehow not so difficult anymore to write down code like this. First this, and when I had that, okay, and the other way around.
Okay, then big thank you to you both. Thank you, Frank. Thank you, Achim, and we see us tomorrow.
Bye. Have a nice day.
Bye.